y-intercept. I plug in a 0 for x. F of 0 is 0 squared over 0 squared minus 4. 0 over negative 4 is 0. My y-intercept is the point 0, 0. Horizontal asymptote. My degree on top is 2. My degree in the denominator is 2. When the exponents are the same, I divide coefficients. My horizontal asymptote is going to be y equals dividing leading coefficient of 1 by leading coefficient of 1. Y equals 1. I factor. The numerator does not factor, but the denominator factors by difference of squares. When I go to check my excluded values, I realize my domain is all the x's except x cannot be negative 2 and x is not equal to positive 2. In interval notation, it would be negative infinity up until negative 2, union negative 2 to 2, union 2 to infinity. I include all the numbers, just at negative 2 and 2 I take a break and I make sure to write them in order. I cancel. Nothing cancels. I do holes. If nothing canceled, there aren't going to be any holes. And then I do my vertical asymptotes. Vertical asymptotes there will be, because these excluded values that didn't cancel, those are my vertical asymptotes. X equals 2 and x equals negative 2. Last step is I look at my x-intercepts. That's the zeros of the numerator. What are the zeros of x squared? Oh, that's just x equals 0. My x-intercepts is just the 1 point, 0, 0, which I already have on my graph. I'll do a little yellow dot on top of it to say I graphed it, but it's the same point. I don't need to graph it twice. Now I can throw down some graph, but I don't really know what the graph looks like, because on the right, I'm not sure what it's going to be. On the left, I'm not sure what it's going to be. And in the middle, I could be doing 100 different things. I could be doing this, or I could be doing this, or I could be doing this, or I could be doing this. No way to know. There is a way to know, though. It's making a table. That's what I need to do. I make a little table for myself. To find out what's happening to the left of my leftmost vertical asymptote, I'll plug in an x value to the left of it. Like negative 3 I'll plug in. That's the left of negative 2. If I plug that in, I'm going to plug it into the original one. I just think it'll be easier. I get negative 3 squared over negative 3 squared minus 4. 9 over 5. Negative 3, comma, 9/5 is just short of 10/5, just short of 2, so that's like a point here. I guess my graph must do this. To the right of the rightmost vertical asymptote, I'm going to plug in one of those x values, like 3. 3 is to the right of 2. If I plug it in, I get, again, 9 over 9 minus 4. X squared is still 9, so negative 3 versus 3, it's the same value. Both of them come out to 9/5. 3 9/5, that's like here. In the middle, I want to be careful because there's so many possibilities. I'm going to plug in a couple x values. I'll plug in negative 1 and get negative 1 squared over negative 1 squared minus 4. And I'll also plug in positive 1 and get positive 1 squared over positive 1 minus 4. Oh, it looks like I got the same thing again. 1 comma negative 1/3 on both cases. Means my graph's going to be close to the vertical asymptote, hit these points, be close to the other vertical asymptote. My range in this case is tricky. My range, I think about the x value, the y values where I hit the graph. Starting at negative infinity, I have all these spots where I hit the graph, hit the graph, hit the graph. The first time where I have a y value that doesn't appear on the graph is right at 0. 0, I still hit the graph. I still have a point on the graph with a y value of 0, so I do include 0 in my range, but after 0 I take a break. And I don't actually start hitting the graph again until I'm at like 1. After 1, I do start hitting the graph again. At 1, I'm still not hitting the graph, so I don't include 1. But after 1, I do keep hitting the graph all the way up until infinity, so I go all the way from 1 to infinity. That's my range. It's a trickier one.